Thank you, everybody. Good afternoon, and thank you for choosing us over the Joe Biden speech. I promise you'll get a high level of content and a low level of politics in what you hear this afternoon. Welcome to the side event on the 2022 Global Carbon Project Carbon Budget. New introduction to scaling solutions from Stanford's new school and the role of agriculture in climate change solutions. I'm Chris Field. I'm the director of the Stanford Woods Institute for the Environment, and it's a real thrill to welcome everyone here today. The overall run of show is that we'll be divided into 3 sections with a plenary presentation on the global carbon budget from the Global Carbon Project, an introduction to Stanford's new Stanford Door School of Sustainability, and then finally a panel discussion on the role of agriculture in climate solutions. I want to start out by introducing 2 wonderful colleagues who will lead the presentation on the 2022 Global Carbon Budget. Pierre Friedlingstein is a fellow of the Royal Society and the chair in mathematical modeling of the climate system at the University of Exeter. He also has for several years coordinated the annual carbon budget of the Global Carbon Project, and he'll be joined by Professor Julia Pongratz, who's a professor of physical geography and land use systems at the University of Munich. She's also director of the Forest Management of the Earth System at the Max Planck Institute for Meteorology in Hamburg. Pierre, the floor is yours.
All right, thank you. It looks like we are more competing with the people next door than with Joe Biden. So, okay, I'll do my best. To be clear and loud. Chris forgot to mention that both Julia and I have an history with Chris in Carnegie because we did spend some of our time, long time ago, back in the days in Stanford and Carnegie, working with Chris. So it's a great pleasure to be here. As Chris introduced us, I will present to you the latest on the Global Carbon Budget 2022. So it's an exercise which involves lots of people, lots of academics, more than 100 people across the world, with many organizations. The paper has been published at midnight today, so it's fresh news. And you see on the slide, the title page of the paper and also the multiple websites where all the figures, data, publication from the Global Carbon Budget are fully available. So what do we do? Every year, and this is the 7th edition of the Global Carbon Budget, every year we quantify the 5 main components of the Global Carbon Budget. That's, first the fossil fuel emissions, the gray arrow on the left, the land use emissions, which is the orange arrow, both emitting CO2 into the atmosphere, the fate of CO2 in the Earth system, which is the accumulation of CO2 into the atmosphere, but also the land and ocean carbon uptake, which we call the land and ocean carbon sinks. And when you do the sum of all these independent estimates, they should come to 0. What goes in should be equal to what goes out. Of course, it's not perfect because our understanding is not absolutely 100%. So we have also what we call the budget imbalance, which is the small little... It's not me, it's still there. Oh, it's back. So the budget imbalance, you can see, maybe I shouldn't... Can I still point? Which is like the little red number at the back, which is the imbalance between the sources and the sinks. So, it's not 0, but it's not large. You see, it's like 1 compared to 35 or 40 units which are being emitted, so a few percent. Okay, so I'll start off with the fossil fuel CO2 emissions, and then I will leave the floor to Julia to present the land use emissions. So this is the long-term evolution of the CO2 emission from fossil fuel burning, so burning coal, oil, and gas. And you see the evolution over the last 60 years of the emission of CO2 in the atmosphere. So we start off like around 10 billion tons CO2 being emitted every year in 1960s, and we more than tripled the amount of CO2 we do emit into the atmosphere. The growth rate of CO2 emissions has been about 2% per year on the average over the last 60 years, with like a more rapid increase, as you can see, around the year 2000 because of the massive growth of the Chinese economy, which led to about 3% increase in the CO2 emissions. And since 2010, 2012, you see it's more like plateauing. Well, it's not plateauing, it's still increasing, but not as fast rate. It's about less than 1%, 0.5% on the average over the last 10 years. And if you look at the last couple of years, you see the drop in 2020, I mean, really clear drop because of the COVID-19 pandemic, the recovery of the global fossil fuel emission in 2021, and the latest number that we produced for this year in 2022, where you see that it is slightly higher than in 2021. Our best estimate is about 1% higher this year compared to last year. If you split by the main fuel, I mean coal, oil and gas, I mean of course the long-term story is the same. I mean all fuel use have been increasing over the last 60 years. If you look at the coal first, which is the main component, at the moment it represents about 40% of the total CO2 emission from fossil fuel burning. I mean the coal went up again massively around the year 2000, and then it kind of like plateaued over the last 10 years. And the plateau is a combination of decline in coal use in US and Europe, which is partly compensated by an increase in China, not as fast as the last 10 years, but still, and India as well. And again, you see the decline in 2020, recovering in 21, and further increase in 2022. If you look at oil, I mean, there was regular increase over the last 6 years, massive drop, of course, in 2020 because of, I mean, essentially people not traveling around, even by car or by plane, so massive drop in transportation and oil emissions, but the recovery in 2021, a continuing recovering in 2022. And for the gas, it's a long-term increase in the gas, mainly because of moving away from coal and moving into gas, and a small drop in 2022, sorry. If I go to the big countries level, I mean, you can't produce estimates for 2022 for all countries across the world. So we focus on the top emitters, which is China, I mean, USA, and EU 27, and India. And if I focus on the current year, 2022, I mean, you see it, I can't remember the number. So for China, the global emissions from in China dropped a bit, less than 1%, 0.8% in 2022. This is mainly because of COVID-19 confinement still occurring in China, and I mean reduced economic activity, especially in the construction and building, with reduced need of coal to fuel the Chinese economy. If you look at the EU emissions went down in 2022, and this is mainly because of the war in Ukraine, with a massive reduction in the use of gas in the EU, which is only partly compensated by the coal, which is increasing in the EU, which again is unusual. And the long-term trend in the EU is like a reduction of coal and increase in gas, and this year just the other way around. USA is much more like on the long-term trend. Some increase mainly due to oil consumptions and transportation, which again, is still increasing, recovering from the COVID crisis. I will skip this one because it's a bit too technical. This is just, trying to decompose, the growth rate in the emission in the different, components. Is it the GDP which is increasing, or is it the decarbonization, which is the amount of energy per GDP, or the amount of CO2 per unit of energy? And essentially, when it's below zero, it's a good sign. It's going in the right direction. We are consuming less CO2, so that's on a given year. And then you can try to decompose the change from year to year and what's the main driver. So if you just focus on the last years, you see the big drop in 2020, which is mainly because of the massive drop in the GDP due to the COVID-19 crisis, and then the recovery in 2021. We don't have the numbers yet for 2022 on the kind of composition. This will come in a few months, hopefully. We don't have all numbers. Okay, so this was the story for fossil fuel. I will pass the floor to Julia, and she can carry on with the land use.
Thanks, Pierre. So we've got this other anthropogenic CO2 emission term beside fossil, which is land use change. And there the estimates look like this. So these are the global annual estimates. You see that the land use change emissions are projected to be around 3.9 billion tons of CO2 in 2022. Keep in mind that this is just about a tenth of total anthropogenic CO2 emissions, so it's a minor term compared to fossil emissions. It has a slightly different dynamic, so it goes down, but it's a slight decrease, and you see that the uncertainties around our estimates are much larger compared to fossil emissions, because for fossil we have good economic data to estimate these numbers. For land use emissions we need to rely on models because there's no observational data you could use, because observations cannot isolate only the effect of land use compared to natural dynamics, natural wildfires and such effects. So we rely on models, and this gives you partly some spread. So we'd rather say what's robust is that over the last decades the emissions rate is, remained still rather high. We try to identify the drivers behind this number here, and there I'd like to remind you that land use is a very complex term. So land use and land use change comprises both deforestation and clearing of other natural vegetation. It includes afforestation, reforestation, forestry, which has sources to the atmosphere when products decay, but also uptake when the forest regrows afterwards. So a large range of fluxes that I had combined as a net flux on the previous slide, but now I give you a bit more of detail. So you see the deforestation flux in red, which over the last decade averages to 6.7 billion tons of CO2, so much larger than the net flux. And this remains rather stable and high over the last years as well. There's also emissions into the atmosphere from the drainage and burning of peatlands. You see that with the organic soils, and then other agricultural transitions. On the sink side for CO2, you see fluxes on forests. So that's afforestation, reforestation, and the net effect of forestry. And there, interestingly, we see that these forest fluxes compensate half of the global deforestation emissions. And these seem to be growing over the last decades. Partly that is indeed due to intentional carbon dioxide removal methods such as afforestation, reforestation. Partly it's also not related to climate change protection measures. This is a glimpse at the map. Again, we're looking into the net land use emissions, so everything combined. And you see that, of course, the picture is very diverse across the world and also looks very different from such a map if you looked for fossil emissions. We put in some more details on land use here because the setting is about agriculture and so on. So here's a map for the land use. The key sources of land use emissions lie in the tropics. But there's also some positive signs like the sinks you see in parts of Europe and also partly in small parts of China. So there's an effect of forest regrowing. The top three emitters are, over the last decade are Indonesia, Brazil, and the Democratic Republic of Congo, and they together contribute 58% of the global net land use emissions. So that's a big term, but keep in mind that a large fraction of that is for export to the global north. It's not just carbon cycle models that you can use to quantify land use emissions, but you can also go to the country reporting. Under UNFCCC, countries provide their inventory data, and these look quite different to what we estimate. The country reporting data shows a substantial carbon uptake for land use CO2, while we showed a clear emission term into the atmosphere. So why is that? The reason lies that the terminology is different. It's different definitions that the countries use for the reported data compared to the carbon cycle models. There's an event tomorrow by the IPCC where we explain this in more detail, how this translation between the two definitions is done. Basically, the difference is that we estimate the land use emissions as only the fluxes driven directly by land use activity. We use so-called bookkeeping models to do so. And then everything else that's not related to land use activity is part of the natural terrestrial sink, estimated by dynamic global vegetation models. The country reported data instead uses the fluxes that we assign to the natural sink to the anthropogenic activities when they occur on managed land. So that's where you see that the gray bar from the country reported data is larger than we have only for the red bar of our emission terms. But we can map this approach based on an assessment by Giacomo, who's also here in the audience. And we've done so, and then you find that the numbers are really close. So when we take the natural fluxes occurring on managed forests, that's 6.6 billion tons of CO2 per year for the last decade, and we add the sink to the land use emission terms, which is 4.5 gigatons CO2 per year over the last decade, then we estimate minus 2.1 gigatons CO2, which is really close to the country reported data that globally adds up to minus 2. So there's a good way forward to provide independent estimates and also to track our progress towards the emission reduction targets by directly referring the global carbon budget estimates to the country reported data. If we add anthropogenic CO2 emissions from fossil and land use sources together, then we find that the emissions since 2015 have remained rather constant, and the projection for 2022 is 40.6 gigatons CO2 per year. To close the carbon budget, we need also to look into the sink of the fate of our emissions. And this is a unique feature of the global carbon budget, that we're not just providing emission estimates, but also the fate of these emissions. And of course, the biggest sink for emissions is the atmosphere. Because emissions remained high, the atmospheric CO2 has reached another record with 417.2 ppm projected for till the end of 2022 on average. So that's 50%, 51% over pre-industrial levels. Apart from the atmospheric growth, there's these other two sinks, the natural land sink and the ocean sink. And they together take up around half of the emissions. So that's an enormous ecosystem service that we get for free and that we take for granted. Without that, climate change would be twice as large. This growth in ocean and land sink keeps up with our growth in emissions, but it could be even stronger if it weren't for detrimental impacts from climate change, like droughts or fires on the land side, or the ocean taking up less CO2 because it's getting warmer. What do we learn all this about tracking our progress to mitigation targets?
Thank you, Julia. So, on the last couple of slides, I will, put, the results of the global carbon budget in the context of, climate mitigation, which is, highly relevant, of course, for the COP and 27. So the thing we do and quantify is the remaining carbon budget, which was assessed by IPCC AR6 in 2019, which is the amount of CO2 we can still emit in the atmosphere if we want to limit warming with a given likelihood. In this case, we take 50% chance, 50% likelihood to limit warming below 1.5 or 1.7 or 2 degrees. And regardless of what climate target you choose, there is a limited amount of CO2 that we can still emit into the atmosphere. So these numbers take into account the fact that we also emit non-CO2 greenhouse gases like methane and H2O. We emit aerosols, and they all contribute to the warming. But when you are starting from today, around 1.5 degrees, if you want to go to 1.5, there's a given warming that you can still allow. If you account for the non-CO2, then you have a CO2 warming, and you can translate this warming into compatible emissions. And this is what done by IPCC. We revise the numbers every year using the update estimate from GCB for the global carbon budget, and we are left with, in gray, which is the CO2 which has been used already, which has been emitted in the past and contributes to the current level of CO2 concentration and warming. And in orange, the orange bit of the pie is what is left to be emitted into the future if you want to stay below, let's say, 1.5. So if I take the 1.5 example, you see that we are left with 380 billion tons of CO2 per year. In the slide that Julia just presented, we estimate that the current emissions, global total, including fossil fuel and land use, is about 40. So 380 is essentially about 9 years of current emission. So if we continue to emit the same amount of CO2 every year, in about 9 years, we have a 50% chance to reach a warming of 1.5. If you go to 1.7 or 2 degrees, of course, I mean, the pie is a bit larger, as you can see, and therefore the time you can carry on emitting at the same level, of course, I mean, it goes on a bit. I mean, for 2 degrees, for example, it's about 30 years at current emission. And you can also, I mean, visualize this, and with this graph, which is presenting the historical emission, I mean, starting from the year 2000, from GCB, and the straight line, if you just assume like a very simple linear decrease in your emission from where we are now until the future, reaching net zero, and to be consistent with this, I mean, different targets. And I mean, quite often we use, I mean, 2050 as a time horizon when we need to reach a net zero. And if you want to reach net zero by 2050, I mean, with a simple linear decrease, I mean, the rate of decline is about 1.4 billion tons CO2 per year, which is essentially what we observed during the 2020 COVID crisis. So the effort we have to put in place every single year is comparable to the COVID-19 decline in the emissions. Okay, I think that's it. I will just put this final slide to thank all the organizations that have been supporting the global carbon budget over the last 10, 15 years. Thank you.
So we actually have time for a couple of questions. If anybody shouts it out, I'll repeat the question, and then Pierre and Julia can tackle it.
Pierre, 50% is not very encouraging. That's like flipping a coin. Have you looked at what previously the calculation on a more like a 60 to 70% chance of hitting those targets? What would we be looking at with something a little bit more optimistic than a heads or tails?
Yes, yeah, indeed, you're right. I mean, you can do the math, I mean, starting from 66%, or you can do the math starting from 90%. I mean, the numbers are in IPCC, so you could say, I want to be 90% sure it's not happening, and then the budget, of course, is much, much smaller. You could go the other way around and say, well, you have like a less risky approach and take a more risky approach, take 33% or 10%. I mean, the reason we take 50-50, I mean, there's two reasons. One is these calculations are based on what we call the TCRE, which is a transient climate response to cumulative emissions, which is best estimate from IPCC is 0.45 warming for 1,000 billion tons CO2 emitted. And this is the best estimate, central estimate, which means it's a 50-50. We could take the high end of TCRE, or we could take the low end of TCRE. The high end of the range from IPCC would give you the 33%. The low range would give you the 66%. But I mean, quite usually when we take an estimate, we take the central estimate. So in this case, I think it makes more sense to take the central estimate to make an estimate of the remaining budget. The second reason, if you look at the past warming versus the past emission, of course it's complicated because it's not just about CO2, but it's more aligned with a TCRE of 0.45. We emitted, as I say, 2,500, and the warming is like 1.1, 1.2. So if you do the math, you get to something like 0.5. So these are the reasons why we decide, we give the number for 50-50, but you can go back to IPCC and you can do the math, and you will get something slightly different if you go for 66%.
We can take one more question, especially a quick one.
Hi, Richard Betts from Med Office Hadley Centre and University of Exeter. So for Julia, you noted the discrepancy between your estimates of land use, total land use emissions and the country reports. I agree that yours is more accurate and defendable. Are there any moves to try and get that reconciled and get the country reporting to follow the GCB protocol?
Okay, that's not a quick question. The quick question is, we'll discuss that later. There's voices that say you can never change the countries, we have to live with that. But at least here we provide an operational way of how you can map those two consistently to each other, so you can evaluate them against each other. And let's follow up with that with Giacomo Grassi here afterwards, outside.
Thank you again. Join me in thanking Pierre and Julia and the Global Carbon Project. Now we're going to shift gears slightly and talk about a bold new approach to accelerating impact at scale. And it's my pleasure to introduce Arun Majumdar, who is the inaugural dean of the Stanford Dorr School for Sustainability. And he's also the J. Precourt Provostial Professor at Stanford. Arun.
Well, thank you, Chris, and thank you for being here despite the President Biden's speech. You all should be given awards for being here and not there. I suspect President Biden is not saying the same thing to his audience. Well, let me just say a little bit about the school. I have no slides, I'll just speak. The idea, clearly, this is the defining challenge of the 21st century, and this required a big, bold, audacious effort from Stanford. And this is the biggest thing we have done in the last 75 years. The first school we are launching in 75 years. How did this come about? A little bit of history. When we had a new president and provost come in 2016, generally previous presidents and provosts have done a listening tour to understand what the faculty and students are saying are some of the most important things that Stanford should be involved in. The issues of energy, water, food, biodiversity, ecology, global health, all came up, and of course climate change affects all of them. And we decided that we could group them under sustainability because none of these things are independent of each other. They all depend on each other. The interplay makes it really complex. And so we grouped them under sustainability, and the next question was, like in all academic institutions, to ask the question, what do we do about it? You form a committee. So I was asked to co-chair the committee with Noah Diffenbaugh, who some of you may know. And we were asked to propose an organization within Stanford that could lead this effort. And as you can well imagine, Stanford, this issue transcends all of Stanford. This is not a business school issue only, or a law school, or an engineering, or humanities and sciences, or School of Earth. It's all of the above. And so the question is, what does Stanford do then? We decided at one of the options that we proposed was to create a school. And within the school, was a new kind of structure and architecture, is to balance between tradition. There are some good things that happen at a university, to balance that with some change, with some transformation, because that's what is needed. Because most of the schools that we have at Stanford, and frankly in other universities, were created in the 20th century, some of them in the 19th, and some of them even in the 18th century. So we needed to do something different to address that complexity and the fact that it transcends all of academia and the human experience and the planet. So this was one of the proposals that was picked. And the idea was that, okay, if you have a school, the tradition is that you have departments within the school. That's the tradition. That's where you recruit faculty, you admit students, you offer degrees, and curricula is developed. And we wanted to preserve that. So we have departments, and we've launched some new departments. We launched a Department of Oceans. We think it's going to be very important. And as part of the new school, the Hopkins Marine Center, which is in Monterey, right next to the Monterey Bay Aquarium, is now part of the school. We have a social sciences division, which has two proto-departments, one in environmental behavioral science and the other on global environmental policy. We think social science is going to be very important, especially at scale when it affects human beings and humanity. So we have that as well. So that's one leg of the stool. It's a three-legged stool. One leg of the stool is tradition. And we are changing our curriculum because you cannot teach things like sustainability as a business or law or engineering. It's all of the above, which means we got to teach our students accordingly. The second leg of the school are the institutes. The Woods Institute for the Environment that Chris leads, the Precourt Institute for Energy, and a new institute that we're going to launch on the Institute for Sustainable Societies. Now, the Woods and the Precourt Institute have been around for 15 to 20 years. And what they have done is change the culture within Stanford to create that ecosystem of interdisciplinary folks that can do use-inspired research to solve some problems or attempt at some breakthroughs. Very important. And these institutes, over the last 15 to 20 years, have created this connective tissue across campus of faculty and students to bring them together, and created the connective tissue with the outside world to kind of create this use-inspired research environment. I call them proof of concept. And as I said, we're going to launch the third institute on sustainable societies. We felt while this was necessary, this was not sufficient, because we have an urgency to the problem. And one of the things that we needed to show through our own experience, if we really wanted to make impact, we needed to show proof of scalability. Because if something does not scale and it remains as a research paper or in a laboratory, it doesn't matter as far as impact is concerned. It's great for scholarship, and we value that, but it's not enough for impact. So the third leg of the stool, which is the balancing act, is really the change factor out here, is a third organization called the Accelerator that we are launching now. And this is about impact, and impact has many routes. On the technology routes, Stanford is not a bad place for startups, but this is about scale up as well. This is not just about startups. To understanding the process of scaling, bringing it back to academia, and then hopefully that will help us identify which problems to really solve that are scalable. But this is not just about commercial technologies. This is about policies. This is about policies that affect humanity, affect issues related to environmental justice, etc., are key to our success. And so this is about policy, and the route to policy impact is quite different from the route for technology impact. But they are interplay with each other. And so this is part of our impact story in the Accelerator. And it's not just about policy. It could be a nonprofit. If someone wants to launch a nonprofit to address global issues, well, this is a place to come to now. And this is about platforms, a digital platform that help bring the world together to share data and other aspects that we can work together. So this is about impact, and for impact, we need partners. We cannot, at an academia institution, do it alone. This is governments, businesses, nonprofits, and other organizations that can come together. So that's the third leg of this, and we just launched that. But this is all about how we look at impact. And one of the things that we are adopting as one of our religion is to think about global impact from the beginning. Think globally from the beginning, not as an afterthought. And it's great to be in a place like this where you get to see, this is, I call this the Olympics of climate change. It truly is. And this is about making this partnership so that through our partners, we understand what the real issues are on the ground, as opposed to perceptions that we may have in Silicon Valley. And it is through these partnerships that we can co-create solutions and help implementation. So again, the architecture of the school, the departments, which is a tradition, the institutes that have changed the culture of our interdisciplinary proof of concept research, and the accelerator, this is about proof of scalability and impact that we're just launching. Let me pause here. We are super excited about this. We are blessed with some resources as well, and now it is a question of bringing the whole campus together in service of the world for sustainability. Thank you very much. If you have any questions, happy to answer. If you have any questions for President Biden, happy to answer them too. Okay. Thank you.
Okay, now we are going to move on to the part of the program where we'll have a panel discussion on the role of agriculture in solutions, and for that we have 4 wonderful panelists. I'll introduce them all and then they'll speak in sequence. So first we're going to hear from Allison Chatrchyan, who's a senior research associate at Cornell, where she leads the Climate Smart Farming and Climate Smart Solutions programs. After that, we'll hear from Debbie Aller, who is an extension associate soil health, an extension associate with the soil health program at Cornell, and she's also the program coordinator for the New York Soil Health Program. Then this side event is shared between Stanford, Cornell, and Princeton, and we'll switch over to Princeton for the final set of presentations. Timothy Searchinger is a senior research associate in the Center for Policy Research on Energy and the Environment at Princeton, and he's also a senior fellow and technical director of the food program at the World Resources Institute. And he'll be joined by Janet Ranganathan, who's the managing director and executive vice president for strategy, learning, and results at the World Resources Institute, where she leads the 5-year strategy and oversees research integrity, managing for results, and data labs teams. Allison, the floor is yours, and you can call on me to advance the slides.
While we're waiting for the slides, thank you so much for being here this afternoon. My name is Allison Chatrchyan. I'm here with my colleague, Dr. Debra Aller. We're both with Cornell University's College of Agriculture and Life Sciences. And I wanted to let you know first that Cornell University believes that breakthrough science can be adapted into real-world solutions to address the climate challenge during our most critical decade. Fueled by the collaborative spirit of Cornell's faculty and students, we've just announced the new 2030 project, which is helping to remove silos, activate research, and leverage existing expertise across all disciplines to find solutions now. One of the most exciting things about working at Cornell is that I get to work with colleagues like Debbie, who are natural scientists. I am a social scientist. And today we're going to talk about solutions to climate change from a policy level, some updates of what's happening right here at the COP in terms of policy, and then we're going to take it down to some assessments that we've been working on and solutions. So next slide. So I wanted to give you some context of global policy on climate change and agriculture within the United Nations Framework on Climate Change. And that is the Coronivia Joint Work on Agriculture. It was a decision of that requests SBSTA and SBI to jointly address issues related to agriculture, and it was set up in 2017. Tonight, after 10 years of negotiations, we are hopefully culminating in a draft decision that will decide whether the KJWA process continues or not. And I am really honored to serve on the party delegation from Armenia, so I get to sit at the negotiation table. The KJWA is critically important, I think, because it's elevating agriculture within this UNFCCC mechanism, and it's highlighting and recognizing some really important facts that are driving all of our work here. The fundamental priority of safeguarding food security and ending hunger, recognizing the fact that there are more than 800 million people that face hunger every year, according to the FAO. It's acknowledging that food production systems each have their own challenges and solutions must be context specific. Farmers are stewards of the land, and farmers need to be at the forefront of any decisions made or practices that they're going to adopt. We need science, technology, finance, and capacity building are critical. Tools are available, but new tools are needed. It's urging the parties and relevant organizations to increase their efforts to promote sustainable agriculture. And finally, the decision that's on the table tonight, and the negotiations got delayed until 8 o'clock, so I'm not sure if this will happen, but I hope it will. It's deciding whether or not to establish a new joint work on agriculture and food security under the Framework Convention. So next slide. So now I want to take it down. One of the critical also points noted in the KJWA was the importance of extension globally. And Debbie and I have both worked on this Cornell Climate Smart Farming program. It's an extension program in our state. We were one of two, the first two in the nation, the other being in California. And our climate smart farming extension tools and resources are really driven by the climate data from the Northeast Regional Climate Center at Cornell, that is clearinghouse for all data from NOAA. What we do is we provide research-based data, farm-specific data to farmers anywhere in the Northeast for free. We have an extension team established throughout our state to provide context-specific, locally specific information to help farmers adapt, and then we have developed resources and tools. So next slide. So Debbie's going to take it from here.
Thank you, Allison. So taking this back a little bit, big picture from that Climate Smart Farming program is that Allison and I have been co-chairing the agricultural sector of the New York State Climate Impacts Assessment. So this is an update of the 2011 Climate Report for New York State, and it covers 7 different sectors, and agriculture being one of them. And so I just want to put a quote out there that touch on many different aspects associated with climate change and how it impacts farmers, not just within New York State, although that's the quote is from a New York farmer, but many farmers elsewhere around the country and around the world. Last year, being 2021, we literally would get half an inch of rain in 5 minutes, and we have a weather station, so we know this. These downpours are just absolutely crazy. So we have gone to protected culture for 95% of our crops, mostly plastic-covered high tunnels and exclusion netting for our blueberries, which helps diffuse wind and rain in addition to providing pest control. This costs us about $200,000 US, but now we essentially get no weather-related losses. And the reason I'm sharing this quote is because it talks about the impacts of weather, talks about the adaptation strategies one farmer within New York State is utilizing, and it talks about the costs associated with implementation of these adaptation strategies. And that's very important because there are many farmers out there around the world that do not have the capacity to implement adaptation strategies around climate change. So this is one of the things we're looking at within this New York State assessment, and it's really highlighting the diversity and the scale of agricultural production within New York State. And that picture on the right just shows some of the diversity of cropping systems across the state. It's a very large state with diverse climates and soil types. And what's unique about this assessment compared to the previous 2011 assessment is it really emphasizes adaptation. While we know mitigation is important, we know farmers in particular really need to focus on adaptation and increasing the sustainability and resiliency of their farms. And also this assessment is emphasizing underserved populations, specifically Black, Indigenous, and people of color populations. It's also talking about the cascading and compounding impacts around climate change. As Arun mentioned, within the Stanford capacity, these are systems. So we're talking about integrating across many different scales and across many different sectors. Next slide, Chris. Another one of the big focuses within New York State, the US, let's say, as a whole, and globally, is around soil health. And as a soil scientist, this is critically important and one of the key adaptation strategies for farmers, and can be done by farmers across any different scale of farm, any different cropping system. And so the link between soil health and climate resiliency is critically important. And soil health is also linked with many other ecosystem services, and it's linked directly with human health and nutrition, as you can see in the figure on the bottom right. One of the key things around soil health, which is the integration of the soil physical, chemical, and biological properties, so it really takes a holistic approach to soil management and farm management, is building soil organic carbon, and which offers an opportunity for drawing down carbon from the atmosphere and storing it directly in our soils as a long-term climate mitigation solution. And I want to mention this Soil Health and Climate Resiliency Act that was signed by the governor in New York State, and there are other acts being passed across states in the United States that really are looking at establishing voluntary standards and objectives, or essentially goals, for improving soil health on farms, and acknowledging that these are specific to states, regions, soil types, and climatic conditions. And I just want to clearly show a picture in the middle there of highlighting what I mean by soil health. If you look on, I guess it'll be on your left, you can see a soil that looks a little bit healthier or much healthier. There are lots of what we call aggregates compared to the soil on your right, which is very compacted. And this all has implications for runoff, infiltration, and erosion, and many other factors. So back to Allison.
So coming out of the recommendations of the New York State Climate Assessment for Agriculture that we worked on, and also from the KJWA, it was really interesting to see that there's so many overlapping recommendations and the need for future directions. So directly from the draft KJWA text, parties are noting the need to scale up the implementation of best practices, innovations, and technologies to increase resiliency. These need to be informed by scientific, local, and indigenous knowledge. Both of us have been really proud that the New York State assessment has included the indigenous knowledge from our state. There are many approaches with high potential for adaptation, with adaptation co-benefits and mitigation, including soil health. We need to scale up implementation, and that requires enhanced knowledge sharing, finance, technology development and transfer, and capacity building. There are innovative policy and social approaches, and one of the most successful policy innovations can include extension services and farmers' self-organization, like we talked about. And finally, policy responses in agriculture are more likely to succeed if they consider the role of farmers first and foremost as key agents of change. So we'll take some questions if we have time. Thank you.
Yeah, I think what we'll do is wait for questions until all the panelists have spoken, and then there'll be a good, healthy chunk of time for a Q&A. So let me turn it over now to our Princeton partner, and Tim, the floor is yours.
Well, thanks very much. So I'm Tim Chatrchyan, Senior Research Scholar at Princeton, and we have a combined project with several partners, including the World Resources Institute, about how to reform carbon accounting for land use. And I'm going to explain why, and then Janet will describe some of the things that are going on. The next slide, please. So I think, as you all know, about a quarter of the carbon in the atmosphere is due to land use change. Half of all the vegetated land is devoted to agriculture. At least 75% of all the world's forests have depleted carbon because of harvests. Next slide. And we continue to see massive agricultural expansion. We actually think that the land use change costs are probably significantly higher than have been reported even here in the bookkeeping models. And the basic reason is the evidence is emerging that the FAO data on land use change understates the land use change. So there was a paper by one of the WRI partners at the University of Maryland, Potapoff et al., last year, that essentially found, I think it's the first high-quality satellite interpretation of net cropland expansion, and found that it's been actually accelerating and was occurring at 10 million hectares per year on a net basis, and the gross was double that. That's not even counting permanent cropland. That figure is about 6 times the estimate in FAO data. So we think that the actual land use change emissions are significantly higher, and actually we have an accelerating problem, not a declining problem. Next slide. But we also need a lot more food, as everybody knows. We need more or less probably 50% more food by 2050. And we modeled in our big report, Creating a Sustainable Food Future, one of the things, this third bar is what I'd like to call your attention to, which is what would happen if we tried to provide all the food in 2050 with today's farms? And the answer is we would need to clear another 3 billion hectares of land. There would basically be no forests or savannas left. And what that highlights, and the other slides build in some kind of assumed yield gains and livestock improvement efficiencies, but they don't happen automatically. And the key point here is that unless we have dramatic increases in yield gains at higher than our historic rates, we will clear a lot of land. And that, one of the implications of that is that land is a very, very precious resource. Next slide. So how to think about land? How should we be thinking about land from a carbon standpoint? And the answer is we should think about land itself. The use of land has a carbon cost. Not just the conversion of forest to agricultural land, but the continued use of agricultural land. And this is not a hard concept, but we somehow ignore this in the carbon accounting for land. If we make a factory and build cars, and we know that there are a lot of emissions involved in making the factory, we assign some of the emissions in making the factory to each car. Well, to produce food, we have to start by making cropland. And to do that, we lose carbon in forests and soils. And we should be assigning some of those emissions to every ton of food that you make. But we don't. The general rule is existing agricultural land is viewed as free from a carbon perspective. So if you use existing agricultural land in life cycle calculations, national reporting, even the Global Land Project, although it's trying to serve a different purpose, so this is not a criticism of that at all, but the point is, it is treated as free. If we didn't use the land, it would reforest and regain carbon, just as an example. Next slide. Next slide. We're having a physical problem. So, I mean, the simplest, so what are the implications of this? Well, what do we want our companies to do, our food companies to do? They're trying to reduce their production emissions. You can reduce your production emissions, let's say, by reducing your fertilizer. But if you decrease your yield, we're going to have to clear more land. If you need 45% more food, which is what we estimated between 2017 and 2050, based on a kind of a carbon land equivalent basis, unless you are increasing yields by 45% per hectare, you will clear more land. So what do we need food companies to do? Make sure that we're increasing yields 45% in that time period in their land. There is no target to do that existing. They get no reward for doing that. They're only penalized for doing that if they increase emissions. They're not penalized for not doing that. Next slide. So another place this comes in is in biofuels. Biofuels, of course, when you burn biomass, you're emitting carbon to the atmosphere. It's a carbon-based fuel. But the assumption is, based on these kinds of little diagrams at the bottom left, is that that doesn't count because growing plants absorbs carbon from the atmosphere, and that offsets that. Next slide. But the point is, it takes land to grow plants. So the benefit is displacing fossil fuels. The cost is not using land for any other purpose, whether to store carbon or produce food so other land can store carbon. Almost all life cycle calculations and other accounting for biofuels treats land as free. There is no cost, no carbon cost assigned to that. Next slide. And one of the implications for that, actually, if you'll go, keep clicking. For some reason that's not showing up, the next slide. Can you go back? I'm sorry, go to the next slide, I'm sorry. Click again, maybe there's a part there. No, I don't know, that's weird. Go back, I'm sorry. Anyway, this is somehow or other got misplaced, but Europe is on the cusp of enacting its very ambitious climate plan. You can't see this full graphic, unfortunately, which will be in Nature in about 2 weeks. So Europe, it turns out, is a large outsourcer of food. On a carbon basis, Europe imports more food than it exports. And if you think of it as renting the carbon, it's about 400 million tons of what we call the land carbon trade deficit. So Europe is essentially exported its food production. But what is Europe's plan? Next slide, under the Fit for 55. If you go one more, click it one more, yeah. Europe's plan is to devote 1/5 of the cropland in Europe to bioenergy, to energy crops. And it's already outsourcing land, and it's basically just going to outsource more. And the reason for that is that it treats agricultural land use as free. So what I'm trying to convince you is that the way we're accounting for land has dramatically adverse consequences. So what do we do about that? We're trying to reform accounting in a variety of ways, working with a group of scientists, but WRI is trying to do something tangible.
Oh yeah, great, thanks. So about 20 years ago, I co-founded the Greenhouse Gas Protocol with a colleague at the World Business Council for Sustainable Development. And we developed the first standard, the Corporate Accounting and Reporting Standard, which I was a lead author of. And it's not a bad standard. It focused primarily on emissions, and it's probably the most used standard to date. And one of the things I've learned from that is when you set a standard and you start measuring something, companies, once they do that, they then set targets. And once they set targets, they reduce those emissions. We did not include land use, the use of land use, as having a GHG impact. And as Tim has explained, it certainly does, both from the carbon opportunity cost and from the fact that if you don't use it efficiently in a manner that keeps up with demand, and demand is growing from multiple places right now, and land is a finite, it also contributes to driving land use change. So that's a problem, and we need to fix that. And it also is a problem because some of the actions that are counted in the GHG protocol now, like fertilizer emissions, which a company might reduce at the expense of maybe productivity, that drives this kind of perverse behavior. So we're fixing that. And by the way, this accounting error isn't just a problem for assessing the impact of the agricultural sector. It's also a problem for the forestry sector. Anything that basically uses land, it creates the same problem. It is not creating the incentive to use land efficiently. As I said, land is finite, and there is growing demand from many different sources for it. So the GHG protocol has now gone back around to try and fix that problem. They're working on a draft land use and removals guidance. And they put a draft out. It's being pilot tested by about 100 companies. They're also opening it up for expert review over the next few months. And what that does is it actually proposes 3 metrics, potential metrics, for how to address these land use emissions. One is to using direct land use, and there are pros and cons of each of these. The second one is a carbon opportunity cost, and the third is a measure of land occupancy. And the guidance right now says that companies must use one of these. It can't not use any of them. It can just use, and it has to use it consistently. And so we're testing out to see how these are. And I think it's kind of revealing that when people think about climate change mitigation in the agricultural sector, they don't think about productivity and land efficiency as a climate mitigation solution, but it is. And so we've kind of got to correct that assumption. It's also true for the biodiversity commitment in trying to protect what little's left of natural ecosystems. You know, productivity increases in agriculture is a friend to them. So I'll leave it at that. Thanks, Tim.
Thank you. Let me turn now to a couple of questions for the panel, and we'll have plenty of time for questions from all of you, so think about what it is you want to ask. This is kind of a question for everybody. The theme from Allison and Debbie was that doing a better job of managing farmland can result in an increase in carbon stocks. And the theme from Tim and Janet was that what we really need to do is emphasize the protection of land that's used for things other than agriculture, and use the potential of that land to store carbon. And I wonder how you think about that trade-off, and whether we should be taking advantage of ways to store carbon in agricultural land, or whether the emphasis should be on intensification, almost independent of the consequences for carbon storage.
Well, you can calculate both. So you can calculate, and that is subject to quantitative calculation of what's going to give you the biggest carbon benefit. And in general, when you see papers estimating a large potential for soil carbon, and they're sometimes referred to as thinking of this as carbon farming, actually 2/3 of the savings that they will typically identify are actually not farming. So the biggest number is typically identified as avoided deforestation. The second biggest number identified is peatland restoration on agricultural land. And so only after that do you start getting into these estimates of whether or not you can store a lot of soil carbon on existing working lands. Sometimes there's a tension. So for example, the single easiest way to store carbon on working land is to turn cropland into grazing land. But grazing land produces on average about 1/10 of the food that you do with cropland. So it's hard to imagine that as a scalable technique. So after that, you're focusing on ways of trying to improve farming, existing farmland. And we think, Janet and I have both authored things where we think the biggest potential there is just to improve soil health. And actually the productivity benefits from that are more important than the actual soil carbon gains. But anyway, so that would be my answer.
Just briefly add, I mean, the real prize in soil carbon is to keep soil carbon locked up in natural ecosystems, because that's where there's large amounts of it. It's good to sequester soil carbon in farmland because it has many benefits, including building resilience to climate change. The trick is that we can't do that at the expense of yields, or we jeopardize what little's left of nature.
Yeah, so I think certainly we need to think about both, the trade-offs with non-agricultural lands and agricultural lands. We all eat every day. We need to eat. Everyone needs to eat around the world, and we need farmlands. I think what's so most important is sustainably managing that farmland. Putting carbon back into our soils is critical. There are many ways we can do that, and that's why the emphasis is, I think, on soil health globally. It's implementing practices like no-till and reduced-till, utilizing cover crops, permanent living pasture, integrated animal, or let's say livestock and food in a single operation. And so we need, while we need to eat every day and have that food from cropland, we need to put carbon back into those soils as well. And I don't know the numbers either, as Tim is mentioning, but there are certainly trade-offs, but I think there's absolutely ways we can have sustainable regenerative agriculture and build carbon stocks within our agricultural lands.
I'm not sure the comment about eating every day applies to attendees at a COP. But except for that, it's a great answer. You know, the challenge that Tim and Janet set forth is to increase yields per hectare by 45%. We've gone through several decades of remarkable increases in yields worldwide, and 1 to 2% per year. But an additional 45% is an intimidating number. How do you think about that, Debbie, Allison?
Yeah, so I struggle with this a little bit because obviously genetics plays a big factor into these yield increases globally. But we also need to look at the food waste component of this. There's incredible food waste across the entire food supply chain across the world. There's also many issues around transportation and the fact that we have a lot of post-harvest losses in countries that need a lot of food, especially in sub-Saharan Africa. So I think these are two big components of the equation that I would like to hear, I guess, Tim's response as well on that chart, that post-harvest losses and transportation of getting that food to people who need it. And what was now I missed my other point. And the food waste component around that.
Yeah, so we've modeled all this stuff out and different possible solutions, and trying to deal with demand is incredibly important, and trying to deal with supply is incredibly important. That 45% is not a rash number. That 45% assumes that 2/3 of the people in the planet in 2050 consume no more than half of the animal products that we do in the West. So it could be a lot more than 45%. So we need to reduce meat consumption by large consumers. Beef in particular is extraordinarily land intensive. We need to try to reduce food loss and waste. The challenge with food loss and waste is that it's not 25% loss and waste by one person. That's spread over maybe 5 or 6 parts of the chain, each of whom is maybe losing 5%. So it's not as easy, but it is doable, and there are definitely ways to deal with that. But at the end of the day, we're going to have, as I said, if you don't have any yield gains, you convert literally all of the world's forests, at least in the temperate and tropics. So, so the first thing is don't make it worse by diverting 1/5 of your cropland in Europe to something else. But the second is a whole range of things, and we know, we have, realistically, we got to just take advantage of modern science, to be honest. I mean, that's the opportunity that we haven't had in the past. And then obviously places like Africa, which have fallen behind because of a whole range of practical challenges, not even so much as technical challenges. So.
And Janet, did you want to weigh in on this one?
Just briefly. So remember, it isn't just the food gap that we have a challenge with when it comes to working land. We also have the construction industry thinking about scaling up nature-based timber. We have biofuels and the sustainable aviation fuels. We want actually to protect land for biodiversity purposes, and we want to reforest areas. So there's just mounting pressures. So I get very nervous when asked, well, what about the yields? Does your practice actually put a dent in the increases we need? And then they say, oh, but we're going to shift diets and we're going to reduce food loss and waste. The truth is we need to do all of them. It's not either or. And actually, if you look at progress on shifting diets and food loss and waste, we're not where we need to be on this. So it's everything.
Let me ask one more question. Well, go ahead, Allison, if you want.
I would just like to say you've heard the challenges that we're facing, the incredible challenges, and I think that's why we need strong policy, and we need agriculture to be elevated, to be a mechanism that continues within this framework convention on climate change and within this COP process, so that we're helping countries and working on this issue at a global level to get where we need to very quickly.
Let me ask one more question, then we'll turn it over to questions from the audience. And this issue of increasing yields and pursuing all of the strategies for advancing food security, we often think of as doubling down on industrial agriculture, increasing chemical inputs, increasing mechanization, and increasing the use of genetically modified crops. And I wonder if it feels like it's the case now, based on the latest available information, that that's compatible with the kinds of improvements in soil health that Allison and Debbie were talking about, and what are the things that need to be done in order to take advantage of the benefits of intensification at the same time we're protecting ecosystems?
Well, we also, of course, have to reduce production emissions. So we already overuse fertilizer. If you produce 45% more food, all other things being equal, you're going to use roughly 45% more fertilizer. So we need dramatically improved ways of using nitrogen in particular. But it's really all of the above. I think that it's critical to not be ideological in these things. We need high-tech solutions to reducing inputs. But I'll also say that if you wanted to actually focus on the single most underutilized category of land, is actually pasture in Latin America, where there are literally hundreds of millions of hectares of badly grazed land that could produce 3 to 5 times the amount, including through anybody's idea of eco-agricultural systems. So we need all of the above, the truth of the matter is, and high-tech solutions that actually even continue to increase the output per animal for dairy in much of the world, and also dramatically improved grazing in Latin America. So that would be my answer, quick answer.
Did anyone else want to weigh in on this one?
Yeah, I mean, I agree with Tim. It's going to be an integrated suite of solutions to think about this issue, and improving things like nutrient use efficiency, and thinking about, you know, organic fertilizer and organic amendments on cropland are going to be critical. And I think, you know, thinking about industrial agriculture, it's all about monocultures. And if we look at natural systems, they are far from monoculture systems. And that biodiversity and integrating of many different crops is, I think, going to be very critical from a sustainability perspective. And yeah.
And Janet?
So maybe keep in mind that there's always the field level effects, and then there's the system level effects, and you have to kind of look at both of them together. But I fear that there are groups now that are just focused on the field level effects, which does start to pit the regenerative movement against the industrial agriculture, because agriculture is not very nature friendly, but you have to keep in mind those system effects. And I think we have to sort of remove this polarization. I mean, I think we've got to bring the best of both to address this challenge. But right now it feels very polarized to me. We need to we need to address that.
Okay, thanks everybody. And are there questions from the audience? Please wait for the microphone.
All right. Thank you very much. Catherine Atkin. I'm from the Stanford Codex Center for Legal Informatics and work on climate data policy. So this is a really interesting and provocative conversation. I'd like to hear you talk a little bit about finance, because clearly, you know, and Janet, the GHG protocol has been such a contribution. So clearly figuring out how to account for emissions, but that's not only, you know, to know what the emissions are, it's also to create the financing mechanisms. And so I'd like to hear you talk about carbon markets and how you think about that. I know in this space, when you think about nature-based solutions and co-benefits with mitigation, like how to think about carbon credits in this space.
Well, if I can, there's one very core connection to what I was talking about, which is the standard carbon credit is you reforest land and you get paid for that. Well, what are you reforesting? You're reforesting agricultural land. What about the cost of the food? So my view is that to have any kind of a robust carbon credit, you need to combine either forest protection or forest restoration with yield gains on other lands so that you're not simply moving your food production somewhere else. So that's another example of where I think the accounting is wrong. The largest estimates of natural climate solutions essentially assume that a very large portion of our best grazing land in the world is simply reforested. It's basically about a third of the world's grazing land was historically forested, about 1 billion hectares. So remember the big, 1 billion, we're going to restore 1 billion hectares. That's basically all the world's best grazing land. So how do you do that? Well, you can't do that unless, particularly when we're going to increase demand for beef and dairy, unless you dramatically increase output on the remaining hectares and reduce your demand. So basically you have to factor in the opportunity cost of land into those carbon credits.
So it is disappointing to me that nature-based solutions for climate have narrowly focused primarily on restoration and protection without the obvious realization that if you want to do those things, and land is finite. Remember Mark Twain? They're not making it anymore. You need to do, the produce, protect, reduce, restore, produce more on the same land, reduce demand for land-intensive products, protect and restore. You can't do protect and restore if you're not aggressively reducing and actually producing more on the same land. But the reduce and the produce are not part of the conversation. But they're enabling conditions unless you want people to go hungry, because that's what will happen. And then there's the whole consequences of that. But leaving aside the whole carbon credits, what about the 600 billion in direct support? That two-thirds, the two-thirds of the world production, $600 billion. Why aren't we using some of that?
Another question from the audience.
Thanks. So I agree with everything that has been said up there on the stage, so thanks for that. I'm particularly intrigued by the different accounting for the land use, and it seems very obvious that the deforestation emission should be credited to the product that we're using, and then the consumer can do something out of it with that information. It would lead as a next step to that also in international negotiations you acknowledge that you've got export of such emissions to other countries. We have a study that quantified that a year ago, the embodied emissions in trade for land use. We've had such studies in the fossil sector for a decade, going to consumption-based emissions, and we're still with territorial emissions and how fossils are accounted for there. So do you think there's any chance that internationally for the land use this will be different than for the fossil sector?
So we think there's an alternative to consumption-based accounting. And those studies that you're referring to are a little different. They're talking about the association of imports with active new deforestation. We just want to focus on the footprint, right? I don't care if you're buying, I care a little bit, but if you're using land, whether that land was recently deforested or deforested in the past, you have a footprint, and overall the footprint's going to expand. So the key thing is to think of land itself as having a cost. So take all that land in Europe, 100 million hectares of cropland, it's got a cost. It's got the cost of not storing all that carbon there. And if you factor in that cost, and you're saying, well, look, one of the benefits from that is the food production. If you don't do the food production, you are essentially losing a carbon benefit of that food production. So you have to compare how much carbon it typically is emitted to replace that food with what other carbon you're going to get using your land a different way. So I think it's complicated a little bit, but I think we don't need to go to consumption-based accounting. The best way to think of it is that land itself is a production asset with a cost. And I think that is a psychological change that people have to have. They think of deforesting as having a cost, but the ongoing use of already deforested land is free. And so once you kind of realize that land itself has a cost, and we can figure out ways to calculate that, it changes everything.
We can take one more question.
Yes, hello, Larry Moffat from the Press Club Brussels Europe. A question for Professor Searchinger. You pointed out the problem with the European Union's Fit for 55 program, converting food, land to energy crops. What are your thoughts and assessment of the Common Agricultural Policy, which is a huge funding program that is very much focused on intensive agriculture? And then a general question to the panel. In your analysis, do you take into account the methane emissions from livestock?
So just on the second question, of course, we're talking here about land use, but methane, nitrous oxide, all these other emissions have to be factored into all calculations of greenhouse gas emissions, of course. On your question, so people really focus on the Common Agricultural Policy, and I've written about it. You know, most people think that it doesn't do a lot of good. I wrote a report for the World Bank and looked at what portion of that might actually be doing something for climate change, and it was so negligible you could barely, it wasn't even worth identifying, So obviously that's a source of funding. But the interesting thing is the energy laws are more important. The energy laws basically are going to drive turning cropland into energy crops. The modeling by the Commission itself for the Fit for 55 plan contemplates that a half of the semi-natural grasslands in Europe, which are considered to be biodiversity hotspots, half of those will be lost, in addition to the 20% of the cropland. This is in the Commission's own modeling. So now you have these new laws that say, well, there's a nature restoration law. There's no land to restore. It's all going to bioenergy. There's an anti-deforestation law for abroad. So Europe's going to increase its imports from abroad, but they won't be from recently deforested land. Somebody else will get the blame for the deforestation to make up for the fact that Europe's using their land. So you're seeing it's this failure to account for the footprint. So those are the things that first and foremost have to matter.
Did anyone else want to weigh in on this one? Go ahead, Debbie.
Just to add about the methane thing, I completely agree. Methane and nitrous oxide are other greenhouse gases that certainly need to be factored in. At Cornell University, there are several scientists working on the methane emissions side of things, and our pro-dairy program, as well as other programs trying to model greenhouse gas emissions and how we can improve methane, or let's say reduce methane emissions, not just from the ruminant side of things, but also in terms of manure management from animals.
Go ahead, Janet.
I'm happy to say that we did get a few things right in the first corporate standard. So production-related emissions would be included. So we had that, and we had some tools for those. But I also wanted to say that we also recognize that there were emissions associated with burning biomass. We did not consider them as zero emission sources. So if you read the protocol carefully, you'll see that we required the reporting of those emissions. I hadn't anticipated it would take quite as long for us to come back to start thinking about land use in a more rigorous way, but we did get the methane piece right.
I just forgot to mention one more thing. One of the Cornell professors, Joe McFadden, there's a whole session on methane emissions that I know he is a part of, and I forget what day it is, but there's certainly going to be discussions about that.
Thanks, everybody, and thank you for joining me in thanking our wonderful panelists, and don't leave, because we're fortunate to have closing remarks from one of my favorite colleagues. Debra Roberts is the head of Sustainable and Resilient Cities Initiative in the EThekwini Municipality in Durban, South Africa. And she is also the co-chair of Working Group 2 of the Intergovernmental Panel on Climate Change, where she led the recent assessment on impacts, adaptation, and vulnerability. And Deborah's going to offer closing comments on everything we've heard today and everything we should have heard.
Good afternoon, folks. I must say, I sat there and wondered why Chris invited someone who specializes in adaptation on urban areas to sum up the session. So he either has a very high estimation of my capabilities, or he's looking for revenge for some offense that I'm not aware of. So I'll take both under consideration. So what does this very rich mix? I mean, I think this has been an exciting session, and I almost wish, the president would go away so more people could have been here, because we've had a number of insights into very different worlds, but I think we can join them up and ask some questions about these. So the first from Pierre and Julia about the global carbon budget. Essentially, you gave us the dashboard, and it's an indication that the work of the IPCC and all of the statements we've made about not being on track for 1.5, about creating a world which the UN Secretary General described, our report as an atlas of human suffering, is going to be characterized by continued suffering and inequity. And I think that's a real challenge for us to take on board, because if we're not seeing that dashboard change significantly, you see that emissions are going to be up by 1%. We're going to be producing 40.6 gigatons of carbon for 2022. None of this is bending the curve, which means we're not going to get a bend in the curve on the kind of human suffering and impact that Working Group 2 talks about. And for me, that has real implications for the other inputs that we had in this particular session. If we look at the school that Stanford is creating, there was a lot of speak there about acceleration and ambition and impact. And there was a particularly important comment about the reality on the ground versus perception. I think we have to get realistic. We have to grow up and realize that the reality on the ground at best is going to be suboptimal if the dashboard that the Global Carbon Project has offered us continues in that fashion. And so I would commend the Global Carbon Project, because you bring us this important information to continue doing your good work. But I would challenge Stanford and saying, are you actually looking at the real world? Are you actually going to be training people that can deal with a suboptimal world? It seems that Stanford is talking about a world that there is no pathway to currently. And so I would worry about that. I would indicate that you're going to have to train people who can deal with suboptimal realities, where there's a great deal of suffering, where we haven't bent the curve on some of these key statistics that the Global Carbon Project is talking about. And then when we come to this important issue of land and food, again, there were so many cues there about the real world. Allison spoke to us about the current negotiations, and really thank you for those insights, pulling out key issues in the negotiations that farmers are stewards. The problem is, in these governance processes that make these discussions, the farmers are only recognized as a major group. They don't sit directly at the table. So we're saying precisely the people who are the change agents are not the people negotiating the policy. Fatal flaw in governance. Again, what we talk about and what we hope doesn't actually accord with reality. Finance, this is a finance COP. Where is the money coming from? Debbie spoke to us about that wonderful adaptation from New York State, where someone's growing blueberries and the adaptation costs $200,000. That compared to the reality in Africa with the huge levels of hunger and starvation indicates the huge inequity. And this is something that doesn't come to the fore in these discussions. We talk technical responses, but we're not talking about the huge inequity in the world, which again points us to this very suboptimal future that we seem to shy away from. And then Tim spoke to us with great passion about land and carbon, but we've got to think about the politics. The world is not only about carbon, sadly. And if we begin talking about land as a mitigation tool, and Janet actually picked up on that we can see land playing this critical mitigation role, I can tell you a continent like Africa is going to get very agitated with that. Because already, if you look at our emissions from Africa, this very continent we're currently standing and sitting on, the bulk of our emissions come from AFLU. And that's worrying to Africa, because if we get sort of set with higher mitigation targets linked to land use, that's going to be problematic in a world where there's inadequate finance and support for our actions anyway. Africa sees the use of land as an adaptive tool, not a mitigation one. So just in these statements, we've got these huge political connotations, which I think, when we talk to our science, and all the science is good, I think we need to be unpacking the politics and the societal impacts around this, and probably get a little bit real and incorporate that into our considerations. So I leave all of those challenges out there. Great work, folks. You raised a number of important questions, but still a lot of work to be done to join these dots in a way that makes sense in the real world.
Thank you so much, Debra. Thanks to wonderful panelists from Cornell, from Princeton, WRI. Thanks to all of you for joining us. And Stanford was pleased to help out organizing this. And thanks to all of you. I promise that you heard things here that you would not have heard in Joe Biden's speech. I wish you the very best evening. Good night.